series and parallel arrangement of cells. Let's consider this diagram. Diagram here. That is E1, R1, E2, R2, E3, R3. Now for cells connected in series, the total EMF, that is E, is equals to E1 plus E2 plus E3. Note. Now the total internal resistor is equals to, as R equals to R1 plus R2 plus R3. That's for cells in series. Now for cells in parallel, let's consider this diagram. This diagram here. Now E1, R1, E2, R2, E3, R3. Now for cells connected in parallel, the total EMF, that is E, is equals to E1 equals to E2 equals to E3. That means that they have the same EMF passing through the cell. Now for the total internal resistance, that is 1 over R, is equals to 1 over R1 plus 1 over R2 plus 1 over R3. That is for the total internal resistance. Now, but if you have two resistors, that's R1, R2 in parallel, so the effective resistance will be given as 1 over R equals to 1 over R1 plus 1 over R2. So 1 over R1 is equals to the LCM there is R1, R2. So R1, R2 divided by R1 times 1 is R2. R1, R2 divided by R2 times 1, we have R1. So cross multiply, we have our R1, R2 equals to R into R2 plus R1. So divide through by R2 plus R1, R2 plus R1. So this will cancel this. So our R is equals to R1, R2 over R2 plus R1.